Plot a graph of pH against mass of calcium hydroxide added to hydrochloric acid. Draw a line of best fit. Okay, so we've got a fairly standard question here about graph plotting. These are not unusual and they're easy to get the marks on provided you're careful. So the first thing I'd say is get a pencil. Okay, the number of students that make mistakes on graphs that have done it in pen then struggle to sort them out so they're legible at the end, and they just lose marks. So pick a pencil up, just get a pencil, please. Right, so with graphs, one of the readings is usually going to go up in a stepwise manner. That's the reading that you make the decision about. So in other words, in this experiment, the mass of calcium hydroxide, the increments go up, they're the same every time. So we are deciding how much calcium hydroxide to add to the acid. So we're making a decision about this variable. The one you make a decision about, the one that goes up in the straightforward manner, the stepwise manner, the same increments manner, that one goes on the bottom. So we're starting at 0 and going up to 1.5, and there's 1, 2, 3, 4, 5, 6 readings there. 1, 2, 3, 4, 5, 6, 7 readings there, sorry. Okay, so let's count how many squares we've got to go with. 1, 2, 3, 4, 5, 6, 7, 8. So they're going to fit on the bottom quite nicely, so we can label those straight away. 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75. Okay, so they fit quite nicely down there, don't they? Up the other side now, these do not go up in a straightforward manner because we're measuring those. We've no idea what we're going to do. We're going to measure those. So these do not go up in a straightforward manner. But so let's look at the lowest and the highest readings, 1 and 12. Okay, so we clearly don't have 12 boxes here. Let's count how many we've got. 1, 2, 3, 4, 5, 6, 7. So 6 2s are 12, so we're going to have to go up 2 each time, aren't we? So 2, 4, 6, 8, 10, 12. And now we can plot the points. So 0 is pH 1. 0, now 1 is going to be exactly halfway up between 1 and 2. So there's 5 squares here, so halfway between them is going to be 2.5. So we need to put the x at 2.5 squares up. 1 little square, 2 little square, half a little square, and on the 0. Next one, 0.25 is also 1. So 0.25 is here, and 1 is 2.5 squares up, x exactly halfway. 0.5 is also 1. So 2.5 little squares up, so halfway between 1 and 2 on the 0.5, there. Okay, now 0.75 is 6, so 0.75 is here, 6 is there, so finding the midpoint for those two, the x bang on the middle. 1 is on 11, so 1 is here, and there is 11 halfway between 10 and 12. So that's going to be 2.5 squares up again, isn't it? So 1, 2, 2.5 squares, because there's 5 squares is 2, so 2.5 squares is 1. There we go. On 11, and then 1.25 is 12, just there, and 1.5 is also 12. So once we've got the points plotted correctly, we now need to draw a line of best fit. Now, lines of best fit in science, generally speaking here, are going to be straight lines or curves. And this one happens to be a blend of both of them. So if I were you, because that's nice straight at the bottom there, isn't it? Let's put a straight line just on those. I'll just do that with the ruler. There we go. Kind of up to that point there, and we've got a straight line here. But in between them, we've got a curve, so we mustn't do that with a ruler. If you do it with a ruler, it's going to be marked wrong. That would have to be freehand. So we're going to do, if it's straight lines, we do it with a ruler. If it's curves, we do it freehand. So we're just going to best fit these points. Well, to be frank, these points look pretty excellent. So we are actually going to go through all this data like so. But if we had anomalies, we'd miss them out, or if there was a few slightly above and beneath the line, that would be fine as well. But there you go, that would get you all the marks in the exam for that question. All these questions and more on aylsham-chemistry.com.